Okay, well, MMS is a cryptic name, but the idea is that when the magnetic field of the sun is carried out in the solar wind and reaches the Earth, it has the opportunity to link up with the Earth's magnetic field. And that happens in a variable way. Sometimes it's a very strong connection, other times it's weak. It all depends on this reconnection process that goes on the day side or upstream side of the Earth, and determines whether or not the sun and the storms that come to us from the sun link up to the Earth's magnetic field and transmit energy and plasma into the magnetosphere and light up the auroras and generate a lot of space weather in the neighborhood of the Earth. This, the reconnection that goes on between the sun and the Earth is an example of a process that occurs widely everywhere in the solar system or everywhere in the universe, and it's an important fundamental process that we can uniquely study at the Earth because we can put spacecraft in the middle of the process and make measurements of it, treat it as if it's weather, if you will, instead of as some distant process that we can only see visually. So to treat reconnection as a laboratory that we can study, we have designed a mission with 4 spacecraft that fly in formation relatively close together, a distance that we can control apart from each other, and they penetrate through the core of where reconnection is occurring. It's called the diffusion region. It's a very small region that the spacecraft travel through very quickly, and so in order to see it in 3 dimensions and resolve what happens as it goes by, we have to have the 4 spacecraft, and each of them has to have very high-speed measurements going on, because the entire layer that we believe is at the core of reconnection goes by in less than a second, and that requires very fast measurements. Okay, so in order to get this very high-speed data, high-speed measurements down to the ground, is actually quite a challenge, because the telemetry pipe that we have, the bandwidth or link to the ground, can in no way send all the data that we might gather during a day in the life of the spacecraft. We can only send down a few percent of that data, and so we need intelligent onboard algorithms that look at the data in advance and determine which parts of the data are most valuable for sending to the ground. And we have that system set up, and it even involves some human intelligence on the ground as well as automated intelligence on the spacecraft. So I should mention that in order to support this intelligent process of figuring out what to send to the ground, we do have a huge amount of storage of data. About 4 days worth of data can be stored on each spacecraft and held pending the decisions about which parts of it will be sent to the ground and which parts will not. That's a very important part of the system, and it allows us to involve scientists on the ground on a reasonable schedule where they have a day or so to make decisions. Okay, so what are these measurements that we need to make at very high speeds to diagnose reconnection? And the answer is multiple, but very much meteorological in one way, in that we need to know the plasma or the gas pressure, that is also its wind and direction, its temperature, or how much energy we've got in this gas, and also the magnetic field and the electric field. And I forgot to mention that we also need to know the composition of the gas, how much of what kinds of atoms we have in it, hydrogen, oxygen, helium, and total mass density, if you will. And we need to know the fluctuations of all these things, so that is the noise environment that's present there, what kind of noise the reconnection process is making as it converts energy from magnetic and electric forms into accelerated particles and winds of the plasma. Okay, so how does one end up getting involved in a field like this? I can only tell you my own experience. I started out after college as a high school teacher, teaching a wide variety of topics in physics and math. And the one that really turned me on was astrophysics, if you will, of celestial objects, but with a focus on things that are inside the solar system, the Earth and the Sun and other planets. And so from there, I realized I needed to get a graduate degree, and went to school at the University of Colorado for that. And then from there, you start getting involved in research pretty immediately, and follow your nose to the research topics that interest you the most. I really was most interested in the Earth as a planet, how it got to be the way it is, why it's the way it is, how it is so friendly to living things. And I got interested in auroras because they light up the top of the atmosphere and make a show for us, but they also are boiling gas off our atmosphere into space. And of course the auroras moderated or controlled by this reconnection process that we're studying with MMS. So if you're looking to get involved in this project even, or this field, I think you need to find some kind of a pathway like that. And I wish you luck. Yeah, let me also mention some of the other specialties or activities, disciplines that are involved in doing a mission like this, besides the science and scientists. There's a lot of mechanical, electrical, aerospace engineering that goes into designing spacecraft and operating them, and they contain a lot of computer systems that involve the writing of complicated software and making it work on the spacecraft to do the jobs we need done. So there's really opportunities for everything under the sun in a way, engineering disciplines, including software engineering, and of course there's business people, and we're handling fairly large sums of money and employing outside contractors in many different jobs to make the mission come together, and all of those types of people can get involved in this kind of mission as well.